So in this lesson, we are going to continue our discussion on work and energy. So first of all, we must understand whether work and energy are scalars or vectors. So is energy a scalar or a vector? So energy, and for that matter work, are scalars. Energy is a scalar quantity. It has magnitude, no direction, and it obeys the laws of ordinary algebra. So energy is a scalar. And what is actually energy? How can we define energy? So energy is a scalar associated with the state or condition of one or more objects. So that is how we define energy. Energy is a scalar quantity associated with the state or condition of one or more objects. And what is the SI unit of energy? SI unit of energy is same as work. So SI unit of energy and work is joule. And what is joule in simple terms? In terms of kg meter second. So for that we need the dimension of work energy. Okay, so we start from velocity. What is the dimension of velocity? Velocity is displacement time by time. So therefore, the dimension is Lt minus 1. That is the dimension of velocity. If you forget this, you remember the unit meter per second. So Lt minus 1 you can write easily, because L is measured in meters, time in seconds. So Lt minus 1 is the dimension of velocity. And from velocity we can easily get acceleration. We divide that by time once again. So that is Lt minus 2. And the unit therefore is meter per second square. And from acceleration we get force. Force is mass into acceleration. So we get mLt minus 2. And from there we get work. And that is force times displacement. So multiply this by L. We'll get ml square t minus 2. So from here we realize, in simple terms, joule will be same as kg, because unit of mass is kg in SI and length is meters. So kg meter square. And here is time. Time is measured in seconds. So S minus 2. So joule is same as kg meter square. Second minus 2. So just remember that. Now what is kinetic energy? Kinetic energy is energy associated with motion. And what is the formula for kinetic energy? Formula for kinetic energy is half mv square. When this is valid? Is it always valid? It is valid when V is much less than C. Now some of you may wonder, velocity is a vector. Then how is kinetic energy a scalar? So actually we can write kinetic energy as half m v vector dot v vector. And whenever we do dot product, we get a scalar. So that's how we get half mv squared. And therefore kinetic energy is a scalar.